Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. So today we will continue our session still in the chapter of pressure and fluid statics. So previously you have learned about the basic concept of pressure, P equal to OGH, and then you also have learned about the manometer, barometer. So today's topic still on the same basis of pressure and hydrostatic pressure and hydrostatic force. So for today, we will learn about the hydrostatic force on submerged plane surface. Okay, so we already know that a plate such as a gate valve in a dam, the wall in liquid storage, or the hull of a ship at rest is subject to the fluid pressure distributed over its surface. Okay, so in any plane surface, as long as it is submerged under the water, there will a hydrostatic force on it. So if it is a wall, like an aquarium or anything, there will be a force, hydrostatic force toward the plane. So the concept is simple. We know that the pressure is increased as we go deeper from the free surface. Okay, you already know that P equal to OGH, which is H is the H from the water surface. And then the second concept is PATM will acting on each side. Okay, so we know that P absolute is a combination of P atmosphere and P gauge. So, but in the case of hydrostatic force, the P atmosphere will acting on the both side. So from the inside, from the due to the hydrostatic, and also from the outside, it also the P atmosphere is also acting on the surface. Therefore, pressure acting on the wall is only due to the water level. So, in calculation for this hydrostatic force, we don't need to include P atmosphere in our calculation. The pressure, and then the last concept is the pressure will generate force toward the wall, and how to calculate it is just using the equation F equal to PE. Okay, this is the basis concept for hydrostatic force. So we know that F equal to PE. The P that we include here is P average. So what is P average? P average is OGH, but H in this calculation is H to the centroid of the surface. Okay, how do you know okay? And then the other concept that you need to know is as long you know that it is a force. So force is a vector unit. So for vector unit, it has the combination of magnitude and also the location and direction. So you need to know where's the force is acting on the surface. So to determine where is the point, the force acting to the surface, we use the YP. Okay, YP is center of the pressure. Okay, as you will see here, the force is distributed force. Okay, I think I'm sure you have learned about the distribution force. So for the distribution force, you can determine where the location for if you combine the distribution force to become a point force. Okay, so this is the equation for this case. So what is what I? Okay, I is second moment of area. Okay, so you don't need to remember it. Okay, this is the table. Okay, the centroid and the centroidal moment of inertia for some common geometry. So normally what we ask you is about is just the rectangle, circle, and also the rectangle. Okay, or any of this figure. Okay. So for rectangle, the area is A times B. Okay, I'm sure you can remember it. You still remember it. I think you have learned from year 5, year 4 or something. And then, okay, for circle, for the area is pi r square or pi d square over 4. Okay, I'm sure you also remember it. Okay, and then for I, okay, so for I, okay, I think I change the pointer to the laser pointer. Okay, for I, the second moment of inertia, if it is a rectangular, I equals to AB cubed over 12. A is the horizontal line, and B is the vertical. Okay, so you need to remember that for using this equation, A is the horizontal part and B is the vertical part. Okay, for circle, I equal to pi r power of 4 over 4. Okay, and again, you can special case. Okay, so special case, if it is a vertical rectangular plate, so you need to know that the centroid will be the centroid of the surface will be at the center of the surface, but for YP it is not same with the centroid of the surface. Okay, but in case of horizontal rectangular plane, the hash C and also the center of pressure occur in the same location. It is easier to understand the topic by using several example. Okay, the first example is a tank having an L shape is filled with seawater. Okay, seawater. Sg is equal to 1025. So I hope everybody can remember how to change Sg to density. Can anybody help me? Okay, given is Sg equal to 1.025. So how much is the density? So how to determine the density? Okay, can anybody please switch on the microphone and answer the question? Amsha? Okay, Amsha.
Yes, sir.
Okay, so what is the density?
1035 times gravity 9.81 and times the H 6 meter.
Okay, no, I just want to know the density. Okay, that's correct. The density is 1025. Okay, so to get the density is just the specific gravity time 1000. Okay, a circular watertight door was constructed at one end and hinged at the point B. Okay, this is the door. The door is hinged at point B. Water level hash equal to 6 meter. Calculate the hydrostatic force exerted by the watertight door and the center of pressure. Determine the hydrostatic force acting on the access door. Okay, so there is two questions. The first question is for this circular door. The question asks about the how much is the hydrostatic force and where is the center of pressure. The second question is for the access door. How much the hydrostatic force and where is the location for center of pressure. Okay, so we start with the okay. So we already know hash equal to 6 meter, and for the density equal to 1025 kilogram per meter cube. Okay, just specific gravity time 1000. And okay, we start with the watertight door, this circular door. So for this circular door, there is several steps to do this kind of question. First, you need to calculate the object centroid, HC. Okay, where is the hash centroid? Okay, we already know the total hash is 6 meter, and the door has a diameter of 3 meter. And the centroid for circle is located at the center of the circle. So the hash C is 6 meter minus half of the 3 meter. Okay, 6 meter minus 3 over 2, you got the hash C is now 5.5 4.5 meter from the surface. Okay, you got the HC. And then the second step is calculate the average pressure, P average. Okay, you already got the HC. And then for P average is equal to rho G HC. Okay, rho is 1025, G is 9.81, and HC, we calculate it. HC is equal to 4.5 meter. So you got the P average equal to 45,248 Pascal or 45.2 kilopascal. Okay, you already got the average pressure. Now we move to the third step. Calculate force acting on the door. Okay, the equation is easy. F equal to PA. P, okay, P equal to 45,248, and A is pi r square of pi d square over 4. Okay, you can choose either equation, pi d square over 4 or pi r square. So by calculating it, you got the force is 319,836. Okay. So you will have answered the first question for the force for the watertight door. And then the fourth step is to calculate the location of center of pressure. So where is the center of pressure for this force 319,836 Newton acting? Okay, the equation is HP equal to HC plus I over HCA. Okay, for this question, it is in a the door is totally vertical. Okay, so you will use the equation of HP equal to HC plus I over HCA. And then okay, we start with the calculation for I equal to pi r power of 4 over 4. Okay, so you got for I for this case is pi times 1.5 power of 4 over 4. Okay, you already got the HC before, you already know the A, and now you also already know the I. So just put everything in the equation. Okay, and then by solving this equation, you got the HP equal to 4.625 meter. Okay, this one is the H is 4.625 is meter. Okay. So just simply using this 4 step, you suppose can answer any of the question in hydrostatic force topic. So what is HP? HP is the H from the water surface to the center of pressure. Okay, as I said before, it's supposed to be a distribution force, but we combine the distribution force and become a concentration force. So if you make it to become a concentration force, so we need to know where the location it is acting on the surface. Okay, so that's why you need to know the F, and also you need to know the location where it is acting on the surface. Okay, any question about this for now? No question?
No, sir.
Okay. Okay, so we go to the second part of the question about the access door. So for the access door, okay, so okay, using that simple 4 step. Okay, first calculate the object centroid. Now the access door is in the horizontal position. So centroid will be at the center of the door. Okay, so you know that the whole H is 6 meter and the diameter for this door is 3 meter. So this location is 3 meter from the water surface. Okay, go to the second step, calculate the average pressure. Okay, average pressure, P average equal to OGHT, and then you already know the rho is 1035, G is 9.81, and HC is 3. So you got the P average is 30,165 Pascal. So, okay, P average, and then go to third step, calculate the force acting on the door. The equation is simple, F equal to PA, P equal to 30,165, and A for the surface, where you got the 1.5 times 0.8, it is given on the previous line, from the question. Okay, so from the question it is given that the access door is 1.5 meter times 0.8 meter. Okay, so you got the force acting on the surface is 36,198 Newton. And now go to step 4, calculate the location of center of pressure. Okay, we already know that for horizontal surface, the location of HC and HP is in the same H from the water space. Okay, because it is horizontal, so any point on the door is in the same H from the water surface. Okay, I think this one is easier from the first part of the question. Okay, we go to the second example. Okay, there is a wall here, and then where's the question? Oh, I missed the question. Okay, there is a door here, and the door is the total H for the water is 3 plus 2, 5 meters, and the door is, I think it's about the width of the door is 6 meter. Okay, so I will include the question before I give you the slide. Okay, so for the solution, still using the simple 4 step. Okay, the first is calculate the object centroid. So anybody want to try for this question? Where the centroid for this wall? The total H is 5 meter from the water surface. So for the centroid, where should it be? Anybody? So, okay, the second name appear here is Mohana Krishnan. Can you please answer? Where the location for the centroid? It is rectangular. So for rectangular, where the centroid? Okay, next, Ahmad Abdullah.
2.5.
Okay, 2.5. So the centroid will be at the center of the surface. Okay, so you know that the total H is 5 meter. So for the HC is half of the H, 2.5 meter. Okay, and then calculate the average pressure, P average. So simply P average is equal to rho GHC. Rho is 1000. Okay, G is 9.81, and HC, Abdullah has answered before. HC is 2.5. So you got the P average equal to 24,525 Pascal. Okay, the third step, calculate force acting on the door. F equal to PA. Okay, just include all the data you know. Also, the width of the door is 4 meter. So you now got the force acting on the surface is 490,500 Newton. Okay, the fourth step, calculate the location for center of pressure. Okay, the equation is HP equal to HC plus I over HCA. And I for this question, okay, it is rectangular. So as I told before, for rectangular, the equation for I is equal to AB cube over 12. A is the horizontal part of the what is it of the wall, and B or phi is the vertical part. So AB cube over 12, A is 4 and B is phi cube over 12. Okay, so for the equation for HP equal to 2.5. 2.5 is the HC plus I over HCA. Okay, and then by calculating it, you got the HP equal to 3.33 meter. So for this question, actually this question asks you about the force acting on the thrust CD. How much is the force acting on the thrust CD? So before that, HP is equal to 3.33 meter from the water surface, or 1.67 meter from the hinge. Mean phi minus 3.33, you got the length from the hinge is 1.67 meter. Okay, to determine the force acting on the thrust CD, okay, I think this define the best for the free body diagram for this case. So for B, it is a hinge, and then you got force FCD. Okay, you need to determine what is the force, and then you know that hydrostatic force acting on the surface is 490.5 kilonewton, and it is acting 1.667 meter from the hinge. So using the equilibrium equation, we got that moment for if we choose total moment from point B, moment at point B equal to half CD times 3. Okay, half CD times 3. Okay, it is positive. You know that the what is it? Conversion for the sign for anti-clockwise it is positive, and clockwise it is negative. So for force, for moment is force time distance, FCD time 3. And then for the case for this hydrostatic force 490.5 kilonewton, it's going to give clockwise. So it is a negative 460,500 times 1.67. Okay. So by solving this equation, you got the FCD equal to 273 kilonewton. Okay, I think this is just simple static equation. You should able to understand it. Okay, we go to the next example. Okay, hydrostatic force acting on the door. Okay, I choose this example because last 2 weeks there is a case, a car suddenly submerged into the lake, and then normally people cannot open the door when the case of the car drowning in the lake. So we need now we just try to calculate how much force we need to open the door. Okay, or how much the hydrostatic force acting on the door that make people impossible to open the door. Okay, a heavy car plunged into a lake during an accident and land at the bottom of the lake on its wheel. Okay, the door is 1.2 meter high and 1.1 meter wide, and the top edge of the door is 8 meter below the free surface. Okay, the top of side of the door is 8 meter below the free surface. Determine the hydrostatic force on the door and the location of the pressure, and discuss if the driver can open the door. Okay, so this is the situation. The car at the top of side of the door is 8 meter from the water surface, and the door can be assumed to be rectangular, with 1.2 meter height and 1 meter wide. Okay, still using the simple step. First, calculate the centroid. Okay, so for this case, where is the centroid for the door? Okay. Do I need to ask anybody, or okay? I think everybody can get. Okay, so the location for SC is 8 meter plus half of the size of the door. So 8 plus 1.2 times 2. So the location for centroid is 8.6 meter from the water surface. Second, calculate the P average. So P average is rho G HC. Rho is 1000, G is 9.81, and H is 8.6. So you got the P average equal to 84,366 Pascal. Okay, and then the third step, calculate force acting on the door. Okay, F equal to PA. So F equal to P equal to 84,366, and the area is 1.2 times 1. So you got the force is 101,239 Newton. Oh, do you need to calculate the okay? And then lastly, calculate the location of center of pressure. Okay, and then you got the force acting at the 8.61 meter from the surface. Okay, so to discuss if the pupil can open or not the door. Okay, the hydrostatic force acting on the surface is 101,239 Newton. So you can imagine it's about how much? If we take G equal to 10, so it's about 10,123 kilogram. Okay, so an average man, I think can handle about 100 kilogram the most. So for this hydrostatic force is acting like 10,123 kilogram is pushed toward the door. So that's why normally people cannot open the door if in the case of car plunged into the lake. Okay, any question up until now?
No, sir.
No, sir.
So far, so good, sir.
So far so good. Okay. Okay. There will be one question in the exam question about this topic. So okay, I will give a hint in every lecture. Okay, so for this easy topic, okay, so far so good everybody kan. So for this easy topic, there will be one question in the final exam. Okay, example 3. 60 centimeter square gate has its top edge 12 meter below the water surface. It's on the 45 degree and its bottom edge is hinged as shown. What's force P needed to push open the gate? Okay, so for this example, normally the question, the door is totally vertical. So for this time, it is a case where the water is not totally inclined, but totally vertical, but have some inclined degree. Okay, for this case, the inclined degree is 45 degree. So how to solve this question? Okay, you know that 12 meter from the water surface and the door is 0.6 meter. Okay, first, still using the same step to get the HC, 12 plus. Okay, now you know that this is inclined, so you cannot take 0.6 over 2, but you need to include the incline trigonometry. So you need to 0.6 over 2 times since 45. So you got the HC is 12.21 meter. Okay, second, you can calculate the P average pressure. Okay, P average I think is simple. Go GHC, just include everything. Go is 1000, G 9.81, and HC you calculate here is equal to 12.21, 12.1. So you got the P average, and then calculate the force acting on the door. Okay, it's also simple. F equals to PA, 109,780 is the pressure, and A is 0.6 times 0.6. Okay, the door is 0.6 times 0.6. So you got the F equal to 43,120 Newton. Or you can also answer it as 43 kilonewton. Okay, next is the location of center of pressure. Before, I usually use the HP equal to HC plus I over HCE. But for incline, you need to use the easiest. It's easier for us because we can remember the difference between HP and HC. So Y is for the incline length. Okay, for H is from the from the vertical. So YP equal to YC plus I over YCA. I equal to 0.6 over 12. But for the YC, okay, YC is 12.1 over since 45. YC is the incline length from the water surface until to this point, inclinely. Okay, 12.1 over since 45 plus I, okay, I normal calculation over HCA. Okay, HC again, and A is I made a mistake here. 0.6 times 0.6. So can simplify here. Okay, can you understand for this case? Okay, by calculating it, you got the YP equal to 17.27 meter from the surface. Or I think this figure explain it. So the YP 17.27, it is the length from the water surface to the point of pressure, but it is calculated in incline. It's not in the vertical. Okay. And then this is from the top of the door until the water surface. Okay, you know the force acting is 43,120, and now you need to know what is the force P needed to open the door. Okay, so you know the hinge here. So to get the moment equal to F over F times D, force time distance. So you need to know this distance. So this distance is 0.6 minus 7. Okay, this two thing. So you get the this distance is 0.3 meter. Okay, equilibrium equation again. Moment at hinge is equal to 0. P times 0.6. Okay, P times the length is 0.6. And the force, hydrostatic force, is 43,120. And the distance is 0.3. Here, you got here. So solving it, you got the FCD equal to 21,560 Newton. Okay. Okay, for this example. Okay, this is the first example, but I don't want to solve it here. But I think you can solve it by your own. Okay, try to solve it first, and then we discuss it next week or later. Okay, we go to the second slide. Part B. So you already know about the hydrostatic force. Now we learn about the buoyancy. Okay, buoyancy force is the upward force a fluid exert on a body immersed in it, and the buoyant force is caused by the increase of pressure with depth in fluid. Okay, you know that it's actually the buoyancy force is also same concept with the P equal to H. So, but there is a hydrostatic force acting on the surface. So, due to the hydrostatic force, this make we feel anything under the sea is much lighter compared to the object outside the water. Okay, as example, if you go to any swimming pool or anything, you can hold your fan with just one hand. Okay, because the buoyancy force is also acting on the surface, on the object. So for buoyancy, the famous principle for buoyancy is Archimedes principle. Okay, Archimedes say that the buoyant force acting on a body immersed in a fluid is equal to the weight of the fluid displaced by the body, and it acts upward through the centroid of the displaced volume. Okay, so you know that Fp, the buoyancy force, equal to weight of the fluid displaced, and you know that weight equal to mg, and for m is equal to density times the volume of the object. Okay, so to determine the buoyancy force acting on any object, you can just use this equation: Fb equal to OVG. Okay, staying of fluid. Okay, for floating body, the weight of the entire body must be equal to the buoyant force, which is weight of the fluid whose volume is equal to the volume of submerged portion of the floating body. So, okay, because the difference on weight, okay, the object has its weight, and the volume of the fluid displaced is also have the weight. So to compare either an object is sink or float, we can use the density of the object. If the density is less than the fluid, then it will be floating. If it is equal to the fluid, it will be suspend body. But for the sinking one, is the case for if the density is much higher than the fluid. Okay, we go to the first example. Wedge loss of an object in seawater. Okay, this is just a concept to understand the concept for the buoyancy force. Okay, a crane is used to lower a wedge into the sea. Okay, the density here is density for the fluid, density 1025 for an underwater construction project. Determine the tension in the rope of the crane due to a rectangular concrete block. The dimension is 0.4 times 0.4 times 3 meter. Okay, the density for this concrete block is 2,300 kg per meter cube when it's suspended to the air and completely immersed in the water. Okay, first we need to determine the tension on the rope if it is still suspended in the air. So to solve any question related to the buoyancy, okay, what you need to do is to get the free body diagram for the object. So for this case, okay, if it is still lift on the air, so Ft equal to the weight of the object. Okay, only two force acting on in here. Okay, the Ft, the tension of the rope, and W, the weight of the concrete block. Okay, you know that to get the Ft, the tension of the rope, is equal to weight of the block, and the weight of the concrete block is equal to OGV. Okay, weight is equal to mg, and m equal to O times v. So that's how we got this equation OGV. Okay, the V for the concrete block is 0.4 times 0.4 times 3. It is 0.48 meters cube, and hence the tension of the rope is 2,300 times 9.81 times 0.48. So you got the tension of the rope is 10,830 Newton. Okay, this is the tension of the rope if it is lift in the air. Okay, if it not is still not submerged in the water. Now the second question, the second part B is completely immersed in the water. Okay, now the cube is in the water. So how much the tension on the line? Okay, so first, still the free body diagram. Okay, now there is three force: the tension on the rope, the wedge, and the buoyancy force. Because the cube is now submerged into the water. Okay, so Ft equal to W minus Fb, and you already know W. Okay, W for concrete is OGV concrete block, and the buoyancy force is OGV for the water displaced. Okay, because the cube. Okay, the concrete block is 0.48 meter cube. Hence, the tension of the rope is the density of the concrete block is 2,300. Okay, G is 9.81 and and V is 0.48 meter cube minus the density of the C, G, and the volume of the cube. Okay, because the volume of the water displaced is the same with the volume of the volume of the cube, because the cube is totally submerged. So now we got the Ft equal to 6,003 Newton. Okay, so you can see that the difference is before it is submerged into the water, the tension is 10,830. But now when it is fully submerged in the water, the tension becomes 6,003 Newton. The buoyancy force is another 4,000 acting here. Okay, any question until now? Okay, understand? So still an easy topic.
Understand, sir.
Okay, one of this not one is the question. Question in topic of buoyancy will be included in your midterm test. Okay, we go to the second example. A cylindrical tank has a diameter of 450 millimeter and length of 750 millimeter. Okay, the diameter 450 and the total length is 750 millimeter. When the tank is floating in the kerosene, okay, kerosene with the density is 823 kg per meter cube, with its long axis vertical as shown, okay, like this. So determine the density of the cylinder. Okay, how much is the density of the cylinder? Okay, where can you got the rationale? Okay, I will forward to you after this class. As I told earlier, I will send all the lecture slide and also all the YouTube link. Okay, because for the previous slide, from the YouTube show that it's just 9% who watch the YouTube until now. Okay, still in the to solve this question, still using the free body diagram. So okay, the force acting is just the wedge of the cylinder acting downward, and the buoyancy force acting upward. Okay, so the wedge cylinder is equal to the FB. So you know that OGV cylinder equal to OGV water displaced. Okay, the buoyancy force is equal to OGV, but buoyancy force is the wedge of the water displaced. For the cylinder, okay, this is the wedge of the cylinder. So just include all the data that you have. Okay, you don't know the density of the cylinder. G is 9.81 and V for the cylinder, okay, pi d square over a time hash. Okay, I hope everybody can remember. And okay, this one is the total for the cylinder, but for this part, it is the volume of the cylinder submerged in the water. Okay, it not the total volume of the cylinder, but just the volume of the water submerged into the water. So that's why the volume here is pi d square over 4 times the hash, and hash is just the hash under the water. So solving this question, okay, just one unknown. So density equal to 658.4 kilogram per meter cube. Okay, you can interrupt me if you have any question or you need me to explain more. Okay, we go to the example 2b. So example 2b, if the same cylinder in example 2a is placed in the fresh water, density 1000 kilogram per meter cube, density how much of it H will be above the water surface? Yes, again the free body diagram, W cylinder equal to FB, but now you need to change it, the density of the water displaced into for water. Water is 1000 kilogram per meter cube. The one that you don't know is the H of the water above of the cylinder above the water surface. Okay, by calculating it, you got the H is equal to 0.49 meter. Okay, 0.49 is the H submerged. So for the H on the submerged, you need to 750 minus the 0.49 meter. I think this is wrong. Okay, this is wrong somewhere. Okay, I will change it before I give you the slide. Okay, again the same question with some addition. Okay, before just the cylinder. Now, if still density is 8000 kilogram per meter cube, with the same cylinder size is add to the cylinder, mean attached to the cylinder. Determine how much minimum thickness is needed to make the cylinder totally submerged in kerosene. Okay, same solution. First is the free body diagram. So now, the force is the wedge of the cylinder, the wedge of the steel, and also the buoyancy force. Okay, W cylinder and W steel acting downward. The buoyancy force is the one acting upward. Okay, solve this equation. Okay, OGV cylinder, OGV steel equal to OGV the water displaced. Not the water, the liquid displaced. Okay. So for this question is in the case of water. Okay, water displaced. You got that OGV for this question. For this cylinder, okay, you know the volume already, but for the steel, you know the diameter, but you don't know the H. So just left the H pi d square over 4 times the H. Okay, the H is the one that we need now, the thickness of the steel, equal to the the wedge of the water displaced. Okay, rho 1000, G 9.81, and hash is pi over 4 pi d square over 4 time 0.75 the existing thickness of the cylinder plus hash the thickness of the steel. And solving this equation, you got hash equal to 0.036 meter. So okay, for this question, actually example 2 is the final exam last year final exam for this question. So I hope everybody think that the exam question will be too easy. In it, I'm sure. Okay, next question.
Sir, kita ada midterm mid test tak?
Ada mid test.
Dia cover chapter mana sir?
Ni chapter sampai hari ni. Up until today.
Okay, baik. Thank you sir.
Okay, so
Test week.
Pardon?
Test week 8 sir.
Week 8. Another 2 weeks
Week
from now.
8. Okay sir. Thank you.
Okay, a 4,000 kilogram boat floats with 1/3 of its volume submerged. If 2% get into the boat, this is 3%. Okay, 2% get into the boat. Each of whom mass is 70 kilogram. Okay, the mass is 70 kilogram. What additional volume of water is displaced? Okay, now we know that for 2%, okay, so for 1% is 70 kilogram, or the force is mg, mass time 9.81. So for everybody is 960 Newton. So you now know that the weight of the person is 1,380 Newton. Okay, you know that FB equal to weight of the water displaced. Okay, so the weight of the person must be the weight the same of the buoyancy force acting on the boat. So mass of the water, okay, so from you know the rho Vg, okay, so the mass of the water is the weight over G, so it's 141 kilogram. Now to get the density, m over v, so we got that the volume is 0.14 meter cube. Okay, that's all. Oh, no. Okay, I thought that's all. That's all for the buoyancy. So we could go to the stability. Stability is just for your understanding. There is no question on this part. So we know that we already know if an object go into the water, either it is submerged or it is floating. So, but now the question is it stable or not? Okay. So there is 3 cases. First, stable, laterally stable, and unstable. Okay, for stable, even there is a force acting on the surface, it's still in the same position. Okay, like a boat on the lake, like any boat, any canoe or anything, you give force on it. But it's still in the stable position. But if in case for naturally stable, in case of any small force given, the object will be moving. So for unstable, okay, even there is no force given to the object, it will be moving. So to calculate for any submerged or any floating object, so the calculating is using the G and also B. G is the center of gravity and B is the center of buoyancy. Okay, you already do this experiment on the floating object. So that's why in the floating example, you use some mass and then you put at the left and right and see the buoyancy of the object. Okay, in case, okay, I think this figure tell you a lot. Okay, in case of buoyancy force, the center of buoyancy force is above the center of gravity, so the object will be stable. If it is at the same point, it is neutrally stable. But for this unstable, in case for the buoyancy, centroid of the buoyancy is lower than centroid of the gravity. Okay, so you have calculated in your experiment. Okay, so this is okay, just to get if in case you want to further understand this topic, you need to search for the calculate the GM and everything. Okay, last part is the fluid in the rigid body motion. Okay, I just go to the okay for this part. Okay, in case you need to bring curry in your car, okay, how much height of the curry, the maximum height of the curry, that you know that even you accelerate the car, the curry will not go to the sofa. Okay, this is, but the calculation is very simple. Okay, the equation is just using this equation. Okay, delta V over delta T. Okay, the example is 80 centimeter height fish tank of a cross section of 2 times 0.6 meter that is initially filled with water is to be transported on the back of the truck. The truck accelerates from 0 to 90 km per hour in 10 seconds. If it desired that no water spill during acceleration, determine the allowable initial water H in the tank. Okay, so for this question, they bring aquarium in the tank. So first, you need to determine the A. A equal to delta V over delta T. So the A is 2.5 meter per second over 2. Then for tan theta, okay, tan theta for this for the slope, okay, for this from this equation, tan theta is equal to A over G plus A. A of A toward the Z direction. So the car is in the horizontal direction, so there's no A in the Z direction. So you got the tan theta is 0.255. Okay, the slope in occur when the car is accelerated is 0.255. So from this information, you can calculate that the long side is parallel to the direction, the maximum H is 25.5 meter. But in case for the short side is parallel to the direction of the motion, the maximum H is 7.6 centimeter. Okay, that's all. Okay, to get summarized, this is what you have learned from the first week until now. You have learned about the pressure measurement device, manometer and barometer, fluid static, and today you will learn about the hydrostatic force and also buoyancy and stability. Okay, and also fluid in rigid body motion. Okay, that's all for today.